Hello, everybody. Thank you for joining. For somebody who might not know what the occasion tonight is, it's the Genesis Block Day. So it's Bitcoin, the network's birthday. So it was today in 2009 that Bitcoin, the network started. And if anybody knows anything about Bitcoin, we know that even if it's only been 15 years, Bitcoin means a lot. And to cover the importance of Bitcoin is beyond the scope of this session. But what we are going to do in this session is try to understand how does Bitcoin work by referring to the Bitcoin white paper. So this is the first time anybody in the world got to know what Bitcoin is. This was published on the cryptographic mailing list. I might be calling the forum incorrectly, but this was published on October 31st, 2008. But it was only on 3rd January 2009 that Bitcoin, the network, came into being. So to start the white paper, so we will just to give you a quick heads up on how we do this. So I will be reading through the paper, and anybody who has any questions or comments can just quickly raise their hand, and we can take a pause and go over any of the comments or question. And I'll also be taking bit of fillers between paragraphs and lines to give you some context or to open room for discussion. So yep, let's get started. So Bitcoin, a peer-to-peer electronic cash system. So simply put, the title itself explains what Bitcoin is all about. It's a peer-to-peer electronic cash system. The author of the paper is Satoshi Nakamoto, and here are their contact details. An interesting anecdote about Satoshi is that nobody really knows who he is, and if anybody here is new to Bitcoin, it might come off as a very interesting piece of information because all of us have known that what is the myth around Satoshi Nakamoto. Nobody knows who this person is, if it's a person or group of people, if it's a he or she or they, or nobody really cares because once this white paper was out, anybody in the world can download this and verify how Bitcoin works. And it was on 3rd January that the Bitcoin blockchain started. So from that point, Satoshi Nakamoto was not important to the network as long as the source code and the Bitcoin white paper is open source. So bitcoin.org is the website where you can still find a white paper, download it, go over it yourself, or send it to somebody who you think might be interested. So yeah, here we go. So abstract is where Bitcoin covers what is it about and how it works. So to read through the first line, abstract, a purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. So this one line basically summarizes what Bitcoin is entirely about. So a purely peer-to-peer version of electronic cash. So we are all familiar with online payments and electronic cash by using UPI or any of the other digital methods of net banking or whatever. But what Bitcoin proposes on one hand is a very simple system, electronic cash, but all the power that lies in the system is it being a peer-to-peer version. So if somebody were to ask you what Bitcoin is about, it's a peer-to-peer network, and what it allows you is to send a payment directly from one party to another without going through a financial institution. So in times where the government is growing larger and central banks are changing interest rates overnight, Bitcoin is quite a radical idea, even though it's a digital payment system. So I'll take a quick pause if anybody has any comments or questions or anything to share about the one line. But in my opinion, this is basically the entire idea of Bitcoin.
So I want to add one more thing. Like when we compare it to like PayPal or UPI, it's actually not the same because like the settlement doesn't happen on the spot. And for things like UPI, there's actually a lot of fees which goes behind the scenes, which the government subsidizes. So it's not technically free, even though you're not getting the
Right.
cost. There's big fees going on because the settlement isn't easy. But Bitcoin is straightforward and simple. Even though because we know everything, it might seem complicated. It's just that UPI is more complex and we don't know what's happening.
Yep. Yep.
That's
Indeed.
a
So
proper valid point. In fact, like in the introduction section, we'll go through it. Like Satoshi does identify this. Like there are a lot of hidden costs, and interestingly, that cost is because of like the replaceability that is inherently built in the UPI or other payment systems. So we'll go through it. Let's keep reading.
Shreyan, one
Yes.
more item that comes to my mind is that before this, there was never a payment system which could work without any intermediary. So whether you talk about PayPal, UPI, any other payment method, there is a centralized single intermediary which coordinates or orchestrates payments. And to the best of my knowledge, this is the first time that now this can be done without a single intermediary or any intermediary. That's huge in my mind.
Yep. And that's like another anecdote on Bitcoin is like the innovation of Bitcoin that it did is like basically this paper. This paper basically came and showed like how do you solve the Byzantine general problem without having an intermediary. So whatever you exactly described is like previously before Bitcoin we never had an instance where we could solve the Byzantine generals problem, and the Byzantine generals problem is the problem without that you cannot um, solve the double spend problem for digital money systems. For physical money we don't need it, because you cannot physically copy gold atom, but you can always digitally copy byte sequences. So without Byzantine generals problem, or a solution to it, we couldn't figure out a way to do digital money. The only other way it can be done was like having intermediaries, because the intermediaries works as the generals or the coordinators for the generals, and then you have consistency on the money supply. So that's what the innovation is, and that's what the breakthrough of that paper was.
Yep. Okay. So thank you guys for chiming in. So now we know what Bitcoin is for, and then rest of the abstract covers how we get there. So let's get started from there. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. We propose a solution to the double spending problem using a peer to peer network. So, as Raj pointed out, you cannot copy a gold atom. So, when you transfer a 10 rupee note or whatever dollar or whatever your favorite form of cash, you transfer from A to B without needing to worry about some person being able to spend that 10 rupee at the same time. But this is not the case with digital cash because it's an electronic record and you can send one copy to some person and the same copy to another person. So this is Satoshi's solution to that problem using a peer-to-peer network. So to go ahead, the network timestamp transaction by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. The longest chain not only serves as proof of sequence of events witnessed, but proof that it came from the largest pool of CPU power. So this was quite a mouthful. It covers a lot of technical terms. So I'll open up the room if somebody wants to take a shot at explaining this or has some questions.
Let's move a bit faster, because in this way we are gonna take forever to cover the paper. So
Right.
the paper itself
Okay.
is mouthful. Like the paper, like each line is dense, and you can ponder on each line, and that's actually a very valuable exercise to do. So we don't want to explain Bitcoin here. We all know what Bitcoin is.
Right.
We just want to read through the paper and see what the content of it as quickly as possible.
Right. Yep.
So
That makes
I guess
sense.
like this is something very intuitively understood, like the last line we said, for anybody who has been into Bitcoin. And for starters, people who are here for the first time hearing about Bitcoin or does not have like thorough view of like technical basics, I would recommend Mastering Bitcoin. And that's where you will see like how this whole story plays out. But today we are mostly going to talk about Bitcoin as a story in general, and not as a what is Bitcoin explainer. So let's keep reading ahead, and we have a lot to cover.
Yep. 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 So to go ahead, as long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone.
Right. So this entire abstract is like the shortest technical summary you can find of what Bitcoin is. And what Satoshi did is like nothing fancy. He just pointed out one after another the basic design assumptions of Bitcoin as a system. So if you are a developer, or if you have been working around core or working on Bitcoin protocol layer systems, these you can identify are always the core tenets of the design principles that Bitcoin development or Bitcoin core development specifically is grounded towards. So it's about having a minimal structure, it's about having as low as attack space as possible, and then the nodes can live and rejoin and accepting longest proof of work chain as proof of what happened while they are gone. So this is the consensus mechanism. The last line describe what the consensus mechanism is, and later on we will see more thoroughly like how doing this mathematically allows us to achieve something that is social, which is consensus. And that's how Bitcoin basically works. That was Bitcoin is. It's a long chain of proof of work, and everything about that software, everything else is basically software engineering around that one single concept. Okay,
Yep.
so if no more question at this stage, we can go ahead. Feel free to raise your hand
Yep.
if you have any question or something that is not clear to you. Okay.
So let's continue with introduction. Commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. While the system works well enough for most transactions, it still suffers from the inherent weakness of the trust based model. Completely non reversible transactions are not really possible since financial institutions cannot avoid mediating disputes. The cost of mediation increases, transaction costs, limiting the minimum practical transaction size, and cutting off the possibility for small casual transactions. And there is a broader cost in the loss of ability to make non reversible payments for non reversible services. With the possibility of reversal, the need for trust spreads. Merchants must be wary of their customers, hassling them for more information than they would otherwise need. A certain percentage of fraud is accepted as unavoidable. These costs and payment uncertainties can be avoided in person by using physical currency, but no mechanism exists to make payments over a communications channel without trusted third party. So yes, this covers the point that we discussed at the abstract itself, that why Bitcoin on one hand does seem a simple system, but actually there's a lot of cost that Bitcoin does away with compared to a system like UPI or PayPal, is because all of these costs are because of a trusted third party.
Right.
Go
And
ahead.
this is like a interesting anecdote. Maybe like people will find the first like paragraph interesting in the sense like Satoshi, the first thing Satoshi did was argued that why you cannot have good micropayment in fiat systems, specifically digital fiat system. In physical fiat, micropayment doesn't exist, but in even in digital fiat, you cannot have micropayments. The reason is you have to mediate disputes. And why? Because the transactions are immutable, because it's always on based on the trusted third party to settle the transactions are always immutable, so there is no settlement happening in fiat ever. And the settlement that happens by the end of the month where the bank settles among each other, there is a lot of like mediation and dispute mediation mechanism involved, and that has cost, and that cost is taken up inside the transaction fees. It's a hidden cost, like while doing a small UPI transaction you don't say it, but you will say it while doing a small wire payment from India to USA. You can't do a $10 wire payment because the Western Union is going to take 30% of it. And because of this reason, micropayment becomes unviable, and that's what he will like get probably on the next section. So this is like quite an interesting argument towards having immutability, and because it's immutable you can do away with a lot of needs for mediation, in terms reducing your cost of transactions and making micropayment viable. So this was interesting and quite a nice argument to put forward in terms of having this kind of systems. So anyway, that's just an anecdote I wanted to enter, and let's move ahead from there. If somebody has any question, feel free to go ahead, or we go.
Yep. Just
Okay.
another quick point if somebody is not aware of it already. So, with Bitcoin, you can send as low as 1,000 rupees and as high as 1,000 crore rupees all for the same transaction fee of 600 rupees. So this is the power of this system, because it does not have an intermediary to charge you extra for the amount that you're sending. So yep, this is. So
Okay.
we'll go ahead. So please feel free to raise your hand if you have any question. What is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need for a trusted third party. Transactions that are computationally impractical to reverse would protect sellers from fraud, and routine escrow mechanisms could easily be implemented to protect buyers. In this paper, we propose a solution to the double spending problem using a peer to peer distributed timestamp server to generate computational proof of the chronological order of transactions. The system is secure as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes.
Right. This is another mouthful paragraph, and again goes into a lot of technical details and later on in the proof of work. So let's not try to expand on it, and we'll go ahead as we see the details anyway.
Yeah, if somebody is curious, then cryptography is where the new magic math for Bitcoin comes in. So we don't have the time or the capability to cover it in this session, but do Google it if somebody is new to cryptography. So moving ahead to transactions, we define an electronic coin as a chain of digital signatures. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner, and adding these to the end of the coin. A payee can verify the signatures to verify the chain of ownership. So this is how a transaction is defined in Bitcoin. So
Let's take a bit of pause on the picture. I think that people will
yes,
find it more valuable if we just walk through the picture. So what's showing up over here is what is called as a Bitcoin transaction. And a Bitcoin transaction, the first paragraph basically describes the important things a Bitcoin transaction contains. So it is basically a data that points to somebody's public key and then adds an output as another person's public key, and there are digital signatures involved inside that data in such a way that only the owner of the previous public key can cryptographically produce a valid transaction spending from that public key, because it requires the private key part of that public key. Now we won't go into the public key private key cryptography details, but that's why it's called a chain of digital signatures. So that's what a coin is. When you get a Bitcoin, it basically means you have a data which has a very broad history, a very big line of history of chain of digital signatures, all the way back to a Coinbase transaction of a block. So for every single transaction, you can do this analysis and figure out the chain and find out the Coinbase transaction from which these sats came. And every sats comes from a Coinbase transaction. And then the chain goes on. As people pay from one person to another, the chain keeps on going. And I don't feel like this is a very good drawing of the whole transaction structure, but that's what Satoshi drew. And basically he wanted to provide that same idea. So there is a verify and the sign thing goes on. So by this transaction data, so somebody can sign it and the rest of the world can verify it. That's the core tenet of public key cryptography, and including this kind of like public key data inside this transaction is how the whole coining mechanism works for Bitcoin. Okay, let's move ahead.
yes. The problem, of course, is the payee can't verify that one of the owners did not double spend the coin. A common solution is to introduce the trusted central authority or mint that checks every transaction for double spending. After each transaction, the coin must be returned to the mint to issue a new coin, and only coins issued directly from the mint are trusted not to be double spent. The problem with this solution is that the fate of the entire money system depends on the company running the mint, with every transaction having to go through them just like a bank.
Right.
We need a way for the
I
pay.
like there is a small
Yes.
anecdote over here. Like in this paragraph, Satoshi is basically talking about DG Cash, and that's the eCash mechanism. And for those people who have been paying attention to the current eCash or the Fedimint, so that's the idea of eCash. And the only way we could figure out how to solve the double spend problem back in the eCash days, that was like 1990s, early 90s, and that was having a mint, and that was the major problem, and eventually DigiCash failed because of it, because the mint becomes the central party to solve the double spending problem. Now, next paragraph he will describe like what he does next.
We need a way for the payee to know that the previous owners did not sign any earlier transactions. For our purposes, the earliest transaction is the one that counts. So we don't care about later attempts to double spend. The only way to confirm the absence of a transaction is to be aware of all transactions. In the mint based model, the mint was aware of all transactions and decided which arrived first. To accomplish this without a trusted third party, transactions must be publicly announced, and we need a system for participants to agree on a single history of order in which they were received. The payee needs proof that at the time of each transaction, the majority of nodes agreed it was the first received.
Right. So this is where he is basically describing the problem statement of Bitcoin. Okay, so now we know this was the problem. Now we know double spend can't be solved without trusted third parties, or thought to be can't be solved. So he describes the problem statement, what is needed. What you need is some way of knowing which one came first. That's where the problem boils down to. That's why you need the mint. The mint, because like there is a line where he says like, in order to know, the only way to confirm the absence of a transaction is to be aware of all the transactions. And that's where the blockchain idea eventually comes in. But that was the problem statement, that the mint is the guy who is knowing all the transactions. So you cannot do away with the mint. So what you can do? So here he poses the question. And in the next section, he basically describes the timestamp server. Let's go.
Timestamp server. The solution we propose begins with a timestamp server. A timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet post. The timestamp proves that the data must have existed at the time, obviously in order to get into the hash. Each timestamp includes the previous timestamp in its hash, forming a chain with each additional timestamp reinforcing the ones before it.
Right. So here he started describing a system that looks like a block and a chain. And he is saying about a timestamp server, and this is an old idea actually. In very old newspaper in 90s and 80s, you will see people would have like classified sections of putting random data. After 1960s, there were like New York Times and other big newspaper outlet who had a front page top corner section to put some random data, and people were started putting this random data as a hash offer something, because this creates a thing called proof of publication. It basically means that a bunch of data existed at a specific time. It could exist before that, but it definitely existed by that time. And then it is widely known and publicly verifiable that the hash existed in that particular newspaper. So you cannot lie about it. So it's a very fun social thing to do, and that's another application of cryptography. This is called commitments. And through this idea, open timestamp was the project created by Peter Todd, which uses Bitcoin blockchain as a document timestamping mechanism. But because it makes perfect sense, because intentionally Satoshi was trying to do exactly something like that. He wants to create a timestamping mechanism called a timestamp server, a server which can timestamp data. That means like you have a public record, unfakeable public record, that this was the time when this data existed. And that's the chain that he was talking about, and the hash contains the previous hash. And the chain idea he reached onto because he wants to solve this timestamping mechanism instead of a single server relying on some other kind of mechanism. Later we'll learn that's proof of work. But there he came up with this idea, like he didn't came up, blockchain was already an idea, that you can build hashes from previous hashes from previous hashes from previous hashes and create a unidirectional linked list that go in the back, right? So that's called a blockchain. This construction was, among many other cryptographic construction like Merkle trees, was proposed by David and Stornetta, if I'm not wrong, 1991. People did not find a lot of use case for that data structure, but a major use case that nobody much talks about is like Git, and created by Linus Torvalds 1997 in order to solve the decentralized version control system problem to develop Linux. And he created Git, and if you look at the internal of the Git, it's the first blockchain ever. And the Git commit history is a blockchain. And so the narrative that goes outside that Satoshi Nakamoto invented blockchain or blockchain invented Bitcoin or however they want to put it out there, that's totally bullshit. Because if you do 5 minutes of research technically behind the history of blockchain, you realize like their blockchain has been around. Major example of the project is Git, but apart from Git, there is not much out there. The reason being is like it's a very niche data structure designed for very niche use cases, and mostly happens to be most perfect use case for that is a decentralized consensus building mechanism. In Bitcoin, in case you decentralizedly decide what the money supply is or what are the transaction ordering is. In Git's case, you decentralizedly come to consensus about what is the state of the project. Same kind of problem, very similar kind of solution. So anyway, let's move ahead. Any question at this point? Shoot out, or let's go ahead. Shreyan, if you have any anecdote here, you can add.
Right. So yeah, I think one just quick data point that I think is important is to understand how Raj pointed out the timestamp server is the Bitcoin blockchain. So this is where Satoshi never used the word blockchain, and it's interesting that blockchain was actually not the first. Bitcoin was not the first time the technology of blockchain or timestamp server was used. So this has been in use in Git. So if any software developer here is here, he must be aware that we use something called GitHub to collaborate on any software systems. So it's interesting that blockchain is actually just one component of Bitcoin. But yeah, let's go ahead to proof of work.
And later on we'll see like lot of other components. We'll see Merkle trees and other stuff. So blockchain is one of those data structure. But after that, like once he talked about the timestamp server, so he created a picture of how the server will work. The server is basically going to contain hash which commits to a previous hash, which commits to a previous hash, and this hash is somehow gonna encode or represent a block, and this block's gonna contain transactions. So if you go to the picture above just a bit, the last picture, Shreyan. Yeah,
Yes.
so there is a block that contains a list of items. Each items later we'll see is a transaction, and this block is hashed, and then a hash chain is created. So that's the simple idea of how the blockchain gonna look like. Now he talks about proof of work because that's gonna answer how do you come to consensus. So let's go ahead.
To implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof of work system similar to Adam Back's Hashcash rather than newspaper or Usenet posts. The proof of work involves scanning for a value that when hashed, such as with SHA-256, the hash begins with a number of 0 bits. The average work required is exponential in the number of 0 bits required and can be verified by executing a single hash.
Keep going. Let's keep going.
For our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found that gives the block's hash the required 0 bits. Once the CPU effort has been expended to make it satisfy the proof of work, the block cannot be changed without redoing the work. As later blocks are chained after it, the work to change the block would include redoing all the blocks after it.
Right. So this is how the cumulative effect happens of the chain. So each block requires a certain amount of computation power in order to get solved, and that block contains a commitment of the previous block, which contains a previous block, and in that way. So as you keep on building the chain, what happens is the cumulative addition of proof of work builds up. So you cannot go and undo something that is 20 block deep in the chain without creating a new chain that invalidates the previous last 20 blocks and create the new top 20 blocks. Now, if each block requires a lot of energy, then creating top 20 new blocks is going to create a lot of going to need a lot of energy. So there is specific cost of creating the block. So in this paragraph, what he introduced is like a hashing mechanism that is going to add a specific cost to creation of the data of that block, namely what is the nonce bit, what is the nonce number that you can put inside the block template, and then if you hash with the nonce and hash the whole data, it's gonna have a certain bit of 0 bits, certain number of 0 bits in the start. Now if you are hearing this thing for the first time, it's not entirely going to go to your head, so read through Mastering Bitcoin on that chapter of how does proof of work actually, the nonce and the hashing and the difficulty adjustment works. And there you will find a more detailed discussion of why we set a certain number of digits of zero at the start. Yes, ML, go ahead.
Yeah, so I just wanted to add that like it's not just cost, it is a real world cost. So
Right.
only proof of work has a real world cost. So I think that is what's misunderstood, and there's a lot of different consensus mechanisms
True.
because they just try to add a cost, but yeah, this is a real world cost.
Right. So that's why it's came with the name called work, and work is a physics terms instead of like a general term here. By work, it specifically means like thermodynamic energy and computational energy, flipping bits that you cannot fake. And so that's why like proof of work is a term probably coined by Adam Back for Hashcash. That was also 1998. And here he used it as a spam protection mechanism. So to send email to somebody, you need to do some computation and you cannot fake that computation. And this is an important point because by playing around the concept of work, you can create a lot of other kind of things, namely bullshit like proof of stakes, which is not a real thermodynamic work, which you can game, which can be politicized, which can be like all sorts of social dynamics can be played on that. The only reason proof of work has been chosen and not other kind of version of it is that you need unadulterated vanilla thermodynamic energy backing the maths, otherwise it's just maths and softwares and doesn't mean anything. So yeah, that's a good point, Emil, thanks. Okay, let's move ahead. Next, he describes a bit further about how it works.
To quickly just add one point, so this last sentence, the average work required is exponential in the number of 0 bits required and can be verified by executing a single hash, tells you about the power of Bitcoin requiring a lot of energy to produce it, but for somebody to verify it, it's actually very cheap because you verify only a single hash to know that the block is valid. So this goes into how SHA-256 works, but yeah, do look into it because it's like a fingerprint mechanism for any data.
Right.
To continue ahead, for our timestamp network, we implement the proof of work by increment. I think I've read this already. So yeah. The proof of work also solves the problem of determining representation in majority decision making. If the majority were based on one IP address per one vote, it could be subverted by anyone able to allocate many IPs. Proof of work is essentially one CPU, one vote.
Now, a bit of
The
anecdote over
majority,
there. Like there are many places where Satoshi said something which did not end up being true. This is one of those famous line. Proof of work is essentially one CPU, one vote. Later on, we realized and we saw how the market evolved. It's not one CPU, one vote. It kind of like all this pooling system happens. There are big warehouses happens. Mining got specialized from CPU to GPUs to FPGAs to ASICs now, and this is something probably Satoshi did not envision, or he didn't talk about it in the paper or in much other communication throughout Satoshi's entire period. It was the CPU based system for Bitcoin. Now you cannot do this thing anymore. So that's just
right?
an
Just a
addition onto this, so we can go ahead.
Right. Just a quick question, Raj, that is it not true still that the percentage of CPU power you hold in the Bitcoin network still allows you to produce that many Bitcoin blocks? Is that a simple, true statement?
That's in general a simple true statement. So instead of thinking about CPU, if you take it as a its more general term like central processing unit, or instead of calling that, if you say like what is your processing throughput, so your probability of earning a block reward is proportional to the ratio of your throughput divided by the rest of the network's throughput. So that is always true. You can still mine on your computer, you will just, the probability gonna be so low because the denominator of that ratio is so high that you will never win a block, but in theory it's still true.
Yes. To go ahead, the majority decision is represented by the longest chain, which has the greatest proof of work effort invested in it. If a majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest and outpace any competing chains. To modify a passed block, an attacker would have to redo the proof of work of the block and all blocks after it, and then catch up with and surpass the work of the honest nodes. We will show later that the probability of a slower attacker catching up diminishes exponentially as subsequent blocks are added.
So yeah, this is basically describing the final consensus mechanism. So why proof of work? Because the algorithm that what is true is as simple as this: what is the longest chain at this instant of time? That is the truest chain. And later on he goes on and shows like as the depth of data increases in the chain, the assurance probability that this is true becomes higher and higher and goes on exponentially. So that's why our confirmation targets are standard 6, because that there has been no historical, or like there has been few cases apart from that the standard 6 block reorgs are so unprobable that they don't happen. So beyond 6 block you can consider your transaction essentially settled down or settled in the blockchain. So this is how it works, because then the next step is very simple. You have proof of work, people uses computation to produce blocks or produce nonce that creates valid block, the block goes into chain, and the assumption is if enough honest node creates honest block, then an attacker node has increasing number of cost in order to create dishonest block. They have to outpace the rest of the honest network, and the assumption here is like the rest of the network is honest. Now this is topic that goes into the deepest rabbit hole in Bitcoin ever since its existence, about the mechanism of consensus and forks, and what happens when it goes into contentious forks and miners vetoes and things like that. So we have talked about it a lot in our various different channels. This is a conversation that never gets stopped. And here's another thing that Satoshi was wrong about. It's a technical detail, is like he says like there is a line that goes the honest chain proof of work is essentially CPU, the majority decision is represented by the longest chain. So later on, this longest chain algorithm was moved into the heaviest chain algorithm. So every block has a weighted proof of work into it, and instead of like calculating the longest chain by counting the height of parallel chain, you count the total cumulative proof of work of parallel chains, and that's how you resolve reorgs. Whichever chain has highest proof of work, cumulative proof of work to the tip, that's the right chain. But in the initial implementation it was the longest chain. That means in theory you can have a longer chain with lower proof of work, and in very early versions of Bitcoin that would have been taken up as the consensus chain. So okay, that's all I had to ramble on this part. Like this is another loaded paragraph where a lot of things to be stated, but we'll go ahead from here. I guess the idea is clear at this point to people, how proof of work and the longest chain or the highest heaviest chain is the right chain cumulatively comes and tries to solve the Byzantine generals problem. Because one, you have the transaction history because it's a chain, and then you have a proof of work mechanism by which you can always decide independently what is the right chain. So, and the attackers will always have to incur cost in order if they want to meddle up our little game. So in nutshell, with these three things together simultaneously creates a circular loop, and that's how Bitcoin works. So this is up to this part, up to chapter 4 is basically the entire philosophical theory of Bitcoin design. Later on, we'll talk about networks and some specific details. So this is the time where we can have some general question answer about what we have read so far. I think one more paragraph left, so let's just finish that.
Yes. To compensate for increasing hardware speed and varying interest in running nodes over time, the proof of work difficulty is determined by a moving average targeting an average number of blocks per hour. If they're generated too fast, the difficulty increases.
This is the innovation of Bitcoin. So I think Saifuddin Amos was the first guy who identified this, and many other people technically talked about this. When we talk about what Bitcoin did or what was the innovation, this one single line or two lines was Satoshi's innovation. There were private efforts before Bitcoin by various researchers about creating this kind of proof of work based Byzantine fault tolerant systems. The only thing that everybody missed was the difficulty adjustment part of it. And without this, Bitcoin wouldn't have worked. Without this, entire game would have been screwed up. Inflation wouldn't be controlled, and the market mechanism wouldn't have achieved. The only reason it works is there is an internal dynamic system which adjusts the difficulty of the proof of work by and specifically how many digits of the nonce needs to be zero by the miner. That's it. The difficulty adjustment algorithm basically calculates, it's just 5 lines of code, and it calculates dynamically by self observing the last 2014 block and their time intervals and trying to adjust it to average of 10 minutes statistical block time interval, and proportionately adjusted the number of digits of zeros you need in the nonce, or you need in the hash, sorry. So it's kind of funny in the sense Satoshi just spent 2 lines about talking about difficulty adjustment algorithm. This is the first time, and last time it get mentioned in the paper. In the code also, it's not a very elaborate thing. It's just one single function that is documented very lightly, and that's what glued the whole idea together finally. Everything else that Satoshi did was not innovation, that was already off the shelf element. Proof of work, blockchain, the hashing algorithms, Merkle trees, public key cryptography, all the other elements of Bitcoin has been existing in the literature before 2008. This is the thing that Satoshi kind of can really claim that I created it, and that's the difficulty adjustment algorithm. Okay, so we are learning a bit late. We have 5 more chapters to cover, but rest we can cover more quickly. So we can take a short, quick break of Q&A if people have any. Yes, Faisal.
Yeah, I had 2 questions. Firstly, is it possible for a chain to have the maximum proof of work and yet not be the longest chain? In practice, is that possible?
No. No.
Okay. And the second, yeah. And the second question is that Satoshi mentions in the white paper regarding the nonces and how the number of zeros determine the difficulty. Now the question that I have is that with the increase in the hash rate, the mining difficulty also increases and the number of zeros increase in direct proportion, right? But at the advent of Bitcoin, where let's say a handful of people were mining, or maybe only Satoshi and Hal Finney were mining, the hash rate was very low. Even at that point of time, did nonces have zeros in them?
Yeah. They had a lot of nonces never had zeros in them. The hashes had zero in them. You adjust the nonce such that the output hash of the block has X number of first digits as zeros, right? So in the early days, as we go along, I guess, so let me think a bit. As the number of zeros increases, difficulty goes higher. So as we are going along, the number of zeros in the block space is increasing. At the initial days, there were still zeros, but it was solvable enough by Satoshi's computer in 10 minutes. And there are some research where people did some did some analysis on the very early Bitcoin blocks and figured out that Satoshi probably had a way to control the hash rate of his system. Now, the people think like, even if it did, like there is no known open source, or maybe closed source, but no known open source library out there that could do that, control the hash rate of your operating system or of your laptop or something. Hash is something, a function that you can do, um, that has a constant system time depending on your system RAM and something. So Satoshi had a way, or like he wrote some script in order to like um, modulate his hash. And in the early days, he probably did some experiment in his computer and came up with difficulty number that he started the Genesis block with, such that it was 10 minutes that his computer was generating the block, because for the first 9 or 10 days, I think he was the first guy who was doing it. Then Hal Finney joined in.
So if somebody monitors the blockchain even today, it's possible for them to go through the first few blocks and see with their own eyes and verify the number of zeros in the hashes of the first few blocks, right?
I mean, we can do it right now live. Shreyan, if you have a browser open, we can go to mempool.space,
Yep.
type 0 in the search, and you will see the first block.
Yep. Can you guys see my screen?
Yes. Oh, you have opened it. Yes. So there is
Yeah, the first one, no, the hash.
yeah, the hash. Open the hash. Yeah. Open that hash, and that's the number of zeros that hash contains. Like, if you cursor your mouse on top, like it will show the number. Yeah. So
Right.
amount of zeros. You can check it in Bitcoin CLI also. You get the hash number, and there are like, it seems to me like around 10, 12 zeros are there at the start. If you look at a recent block, you will see more number of zeros. Right. And then like there was a used to be a good tool called BTC RPC Explorer, which has a page of like fun blocks, and there were like some fun blocks and transactions identified in the very early days, like the first transaction from Satoshi to Hal Finney. If you look at block 0, it will only have Coinbase transaction. If you go towards around 9th or 10th of Jan, you will see the first transaction where Satoshi paid to Hal Finney 25 Bitcoin. I guess like a few hundred blocks or something like that. I have to look that up. But yeah, you can do this kind of archaeologies on Bitcoin blockchain, and you will find like interesting things out there.
Yep.
Okay.
Right. So if no other questions, let's go ahead to chapter 5.
Yes.
Network. The steps to run the, I think somebody's unmuted. If can somebody quickly check? But I'll go ahead.
Yeah.
Network.
You're audible.
Okay. Yes. The steps to run the network are as follows. New transactions are broadcast to all nodes. Each node collects new transactions into a block. Each node works on finding a difficult proof of work for its block. When a node finds a proof of work, it broadcasts the block to all nodes. Nodes accept the block only if all transactions in it are valid and not already spent. Nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. So yes, so this is like the consensus of Bitcoin, right? This is where nodes are agreeing to order transactions in this way.
Right. So it's basically 6-step process of what the Bitcoin protocol is. And in this process, Satoshi described nodes and miners as the same thing, because in his design, they were not separate. Every node was miner and every miner was a node. And it was the same software that used to do the wallet, transactions, networking, broadcasting, mining at the same time. So now it's mining is by default off in Bitcoin Core. You can turn it on. But in early days, if you just start the software, it will start mining in your system, and it will create a lot of noise and lot of CPU power and stuffs.
Yes. Nodes always consider the longest chain to be the correct one and will keep working on extending it. If two nodes broadcast different versions of the next block simultaneously, some nodes may receive one or the other first. In that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie will be broken when the next proof of work is found, and one branch becomes longer. The nodes that were working on the other branch will then switch to the longer one.
Right. So this paragraph basically describes an important and interesting thing about Bitcoin consensus. Bitcoin consensus is never definite. So it's basically saying like there is no one known truth at any point of time. The truth kind of emerges as time progress. So the consensus happens eventually. It's an even natural eventuality of the proof of work system that eventually there will be a block that is going to be longer. And if everybody just keep blindly following these 6 steps and keep doing their thing, everybody will be always consistently on consensus, because naturally there will be a longer chain one another. And this is why the natural fork happens. So this is also the idea of reorgs, and 2-3 blocks of reorgs in once in a month or twice in a month is very common in Bitcoin. That's like regular forking happens. And because of this mechanism, a node never knows which is the longest block. And it can happen like it can receive 2 blocks at same height which is equal proof of work, and there is no way for him to know. So it just choose one and keeps building on top of that one until it has another way of knowing that okay, something a next block came which extend one chain or another. So if that's also a tie, then it will wait for the next block. If that also a tie, it will wait for the next block. And because of the nature of proof of work, the probability of tie happening throughout like n number of blocks exponentially decreases. So you can have 1 block tie, 2 block ties are very rare, 3 block ties probability is very, very low. So that's how the system emerges consensus instead of like deriving into consensus. So that's an in like important design and conceptual distinctions to have for Bitcoin developers, or like to cover your Bitcoin basics. Like you don't need it to write code or something, but that's important information how consensus emerge.
Yes, going ahead, new transaction broadcasts do not necessarily need to reach all nodes. As long as they reach many nodes, they will get into a block before long. Block broadcasts are also tolerant of dropped messages. If a node does not receive a block, it will request it when it receives the next block and realizes it missed one.
Right. So
Coming,
yeah, so basically it's basically describes the broadcasting happens in the best effort basis, and the node basically needs to the system is like basically like tolerant of dropped connections, dropped node, and no assumption is made about the consistency of the network topology. The network can be as chaotic as random as possible, and that's one of the neatest thing about the Bitcoin design. It does not need a very concrete structured network. It requires a very loosely held and organic gossip network where each node has parallel footing, there is no hierarchy, and they just do their work in best effort basis, and the protocol allows everything to be streamlined on their own. So let's move ahead. We'll talk about the next part, which is like one of the big part about Bitcoin's design is about incentive, and this is not technical, this is about the economics of the system. So quite fun to read through.
Yep. Incentive. By convention, the first transaction in a block is a special transaction that starts a new coin owned by the creator of the block. This adds an incentive for nodes to support the network and provides a way to initially distribute coins into circulation, since there is no central authority to issue them. The steady addition of a constant of amount of new coins is analogous to gold miners expending resources to add gold to circulation. In our case, it is CPU time and electricity that is expended.
Very clear and crisp as possibly as it can get. Let's go ahead.
The incentive can also be funded with transaction fees. If the output value of a transaction is less than its input value, the difference is a transaction fee that is added to the incentive value of the block containing the transaction. Once a predetermined number of coins have entered circulation, the incentive can transition entirely to transaction fees and be completely inflation free.
Right. So that's where he is describing the miner's reward.
Yes. The incentive may help encourage nodes to stay honest. If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using it to defraud people by stealing back his payments or using it to generate new coins. He ought to find it more profitable to play by the rules. such rules that favor him with more new coins than everyone else combined, than to undermine the system and the validity of his own wealth.
So this is basically
I
kind
think
of Satoshi came and claim that um, the system works not because of the protocol, but because of this incentive circular feedback loop. So, as an individual selfish actor working by the motives of capitalism, you will end up finding to play by the rule as more profitable than attacking the system. If it was not, then the system wouldn't have worked, and this paragraph would be violated, and Bitcoin would fail. So Bitcoin works because this feedback loop works, and the miners and the node runners figured out that it's more profitable for them to play by the system than to attack the system. Okay, I guess we have some question. Ify, go ahead.
The question is, is there a concept of mental block?
Your voice is quite low, so can you like pump it up a bit?
So is it better now?
A bit better, yeah.
Okay, so is there a concept of uncle blocks in Bitcoin?
Uncle blocks. There is a concept of orphan block. I'm not exactly sure what an uncle block is. I think it's similar to orphan blocks, and like blocks on top of which the chain does not build upon. But yeah, there are orphan blocks, and they are kept. I think they are kept, not pruned yet. But there is a PR that was going on last year in Bitcoin Core that old historical orphan block can be pruned.
Okay, so are they still getting rewards in terms of mining, or I mean, I'm just coming from the other side, the Ethereum side, so they get rewarded there. So
No, in orphan blocks in Bitcoin, you don't get rewarded. I think in Ethereum, in uncle blocks, you do get the reward. Miners are allowed to keep the reward, but in orphan block, you don't.
yeah.
The entire chain gets reorged away from the block, and everything in that block is basically invalid.
So for some clarity on this, if so, at what stage you get rewarded? Is it
100
I
blocks after mining 100 after the block you mined has 100 more blocks built on top of it. Miner rewards get paid out in 100 blocks.
Oh, okay, right. Thank you.
Yeah. Okay.
Okay.
That's good Q&A. Any more other questions on proof of work? The next one is bit on basic technical and talks about the SVV system. And we are already like running quite end of our time. So can we just see what are the next places, the next chapters quickly? Reclaiming disk space. This is like
Yes.
SVB and Markle roots. Then here he goes into right. So let's just quickly skim through the remaining of the chapters. So instead of like
Okay.
reading line by line. So the next one, chapter
Right.
7 was, can you just go to chapter 7?
Yeah. Reclaiming this space.
So this is, yeah, reclaiming the displays, and here he introduces the concept of Markle trees. And Markle trees are compact ways of introducing cryptographic commitment of a set of data. And here we are talking about the transaction data. This is something very obvious for anybody, or clear anybody who has gone through mastering Bitcoin or Bitcoin basic tutorials. And this is how a block, all the transactions get committed into a block, and then the block header contains a bit of data which finally gets hashed. It's not the entire block gets hashed, it's the block header that gets hashed. And here he goes into how we can compact that into a Markle tree, using a Markle tree into a block header as a root hash, and we don't have to hash the entire 1 megabyte block. And this is on a bit of technical details and not much anecdotal, so we can just skim through this and go to 8. We don't have to read through. And here he does some calculation on how much data a blockchain header chain will take up. Yeah, this one, 80
Right.
bytes
Let's
into,
go to
yeah. The SPV, this is where Satoshi was blatantly wrong. In this section, he basically goes ahead and describes how how a mobile wallet or a small scale wallet can work without needing the full blockchain. And his idea was like, you can create a block header and you just need the block header to verify the chain and you don't need to do anything else. This ended up becoming false, and the initial idea of simplified verification SPV by block filters did not work and had a lot of privacy and other kind of things. Now we have a better model called BIP 157 and 158, which is like the compact block filter, which is very similar to the block filters that are described in this drawing and diagram, and but has some more extra details. So this is another section where famously Satoshi was wrong, and this didn't pan out how he envisioned it to be.
We want to go with chapter 9?
Yes, chapter 9. This one is another technical bit. So here, like, we are coming out of the design philosophies of Bitcoin and going into some details. So this is where he describes the transaction structure, like how the combination of input and combination of output works. And so we can just quickly read through this. And
All right.
yeah.
Combining and splitting value. Although it would be possible to handle coins individually, it would be unwieldy to make a separate transaction for every cent in a transfer. To allow value to be split and combined, transactions contain multiple inputs and outputs. Normally, there will be either a single input from a large previous transaction or multiple inputs combining smaller amounts, and at most two outputs, one for the payment and one returning the change, if any, back to the sender.
Yes.
It should be noted that fan out, where a transaction depends on several transactions, and those transactions depend on many more, is not a problem here. There is never the need to extract a complete standalone copy of a transaction's history.
Right. So if that's not clear why that's the case, you need to read Mastering Bitcoin, because there are more details about public key cryptography and transaction structure going on. Here he just summarized what this structure enables us to do. This is called the UTXO model. And most other chain probably does not use this because it's a bad structure for smart contracting, but it's a very good structure for validating and data compression. So he went into this UTXO model, and each of this output, that newly created output, is called unspent transaction output. That's where the UTXO name comes from. And this is where he describes this. So let's move ahead.
Privacy.
So
the
like
traditional
here,
banking.
this one gonna be a bit longer. We are at page 6. So there are 3 more pages going on. So this is, we'll just cover like by basics where each one of this section contains. So here he basically chalks out how the network is like private than other banking intermediary systems. So there the diagram basically describes that how you have the trusted third party who is maintaining consistency of the payment histories and the transaction histories, so nobody is frauding anybody else. Here in this new privacy model, you have identities, you have transaction, and then you have a public network. And it's a much more simple model. And the privacy is, so here he talks about how Bitcoin is not anonymous and pseudonymous. And I'm not sure whether he specifies that part, but these identities are what the public keys is, or your Bitcoin addresses. So all you have in as a user of Bitcoin is your transaction and in your public key, and an access to a broader public network via internet. So then that becomes the privacy model of the whole thing, right? So let's move ahead. Yes, go ahead.
So this the privacy model, traditional privacy model that you talk, is it very similar right now what we are doing with Bitcoin, just because of the KYC and came out and
Yeah, that's an argument to have. It like what he described was like how he envisioned the network and the infrastructure to look like. It turns out like it does not look like that, and there are like this kind of structure that can again come up via KIC regulation and policies, and you might or might not be able to bypass them. And that's just part of the fact.
Right.
Yep. And there's a lot
Let's
to be
go ahead.
said and discussed about the privacy aspects of Bitcoin. And there are many people who are working on various different directions and ways in order to improve the situation. And there are like various solutions available for various ways, right? So, but definitely that's an ongoing work in progress thing. And Bitcoin is not a done deal. And these kind of questions are out there. SPV, privacy, scale, throughput, fees. These are like open questions that like developers, Bitcoiners, people working in this space gonna have to solve for next 20, 30 years. So the next section basically is very interesting. It's probably one of the most mathy section of the paper. He does not touch any math before. Now he touches some math, and this is quite some involved and nice looking math, and is probability distribution and binomial like random walk is your thing. This section, walkthrough of this section is going to be fun. And what this section basically describes in a nutshell, there is a graph at the end. Can we just go through that? Go to that at the end, scroll down. So here's he derive bunch of equations, some code that represent that equation, and some plotting. And okay, there's no graph, but there is a plot. So for q let's go to the first table, right? So q equals to like the first table here, yeah, this one.
Yeah.
Q equals to 0 1, z equals to 0, p equals to 1. So q equals to 0 1 is like determines the ratio of attacker's hash rate. Z determines the depth of change the attacker is trying to make in the blockchain, and probability is like what is the probability that he will succeed with that particular hash rate, right? And if you look through, he did that for q equals to 0 1 0 3, and later on the next one is on so next one is on p less than 0. So how q and z changes. So how many depth is required to successfully attack depending on your hash rate, right? So um or I think the z is different. I need to read through like what the probably the z means like how many blocks you can successfully change if your hash rate is 45% of the network with probability less than 0.001, right? And so this entire calculation basically describes how the probability of changing with a given amount of hash rate in the block decreases exponentially with the depth of the block. And this basically validates the security model of Bitcoin. So the security model of Bitcoin is basically described mathematically in this last segment. So that's the last math Satoshi did, and he thought like that's important to prove because that's the first question that he's gonna have. And he modeled the process, the proof of work process, as a binomial random walk distribution, and then came up with some nice equation, plotted those equation in C++, and came up with these numbers, right? And that's the first ever validation he had. Like this paper was published even before the code was published. So that was the first math proof, or the only math proof that we can have, as mathy as it can give. We cannot prove Bitcoin. In fact, like one guy famously said that Bitcoin does not work in theory, but it works in practice. So that's as much as proofy you can get with Bitcoin. So then the next section is conclusion. I think that's going to be another interesting read through. So let's just read through that, and we'll end up with a short Q&A session.
Yes. Conclusion: we have proposed a system for electronic transactions without relying on trust. We started with the usual framework of coins made from digital signatures, which provides strong control of ownership, but is incomplete without a way to prevent double spending. To solve this, we proposed a peer to peer network using proof of work to record a public history of transactions that quickly becomes computationally impractical for an attacker to change if honest nodes control a majority of CPU power. The network is robust in its unstructured simplicity. Nodes work all at once with little coordination. They do not need to be identified since messages are not routed to any particular place and only need to be delivered on a best effort basis. Nodes can leave and rejoin the network at will, accepting the proof of work chain as proof of what happened while they were gone. They vote with their CPU power, expressing their acceptance of valid blocks by working on extending them and rejecting invalid blocks by refusing to work on them. Any needed rules and incentives can be enforced with this consensus mechanism.
Right. So basically, that's Bitcoin in a nutshell. It's a consensus mechanism. It's a mechanism to achieve consensus in a distributed environment with economic incentives and double spend resistance, solving finally the Byzantine generals problem. So that is Satoshi's mic drop piece. And when this paper was dropped, it did not attract a lot of attention. It did not was a not a celebrated thing. Very few people read it. Very few people commented on it. People started taking it seriously few months after the code was launched, which is like exactly 15 years from before now today, 3rd Jan. And the code was probably launched after 3rd Jan, and after the blockchain was mined, and then people started running the code on their system, and the rest is history. So yep, this was a fun read. And so now we open up for a general discussion and Q&A, and then we can drop. Somil, yes, go ahead.
Yeah, so I have a doubt. Like, let's suppose a case where a miner adds a corrupt transaction in his block and is mined, and another block is added on the top of it. So,
What do you
the
mean a
network,
corrupt transaction? Wait. What, like, first step is like, what do you mean by a corrupt transaction and that got mined?
like, he adds a he basically changes the transaction. Like, he's able to change the transaction,
Why would other
or
nodes accept it if it's invalid by the protocol?
like, and he is only the one who is mining it. Like, he's able to do it.
If you have only one miner, then it's a centralized system, right? So that's why like every node is a miner, at least by the paper, and now you have a situation of multiple miners. So the reason that situation cannot work is like if you create something invalid, even if you are a miner, other miners will not accept it, and the
Yeah,
rest of the network will not propagate it.
but if we do have enough computational power, it exceeds the majority computational power there on the network.
That's
Will
the
be able
theory
to.
of 51% attack, but that does not
Yeah.
work in practice. And a short answer to that is block size war. And the long answer to that is like, look what happened in 2017 when 85% of the miner kind of like decided to do something, and that got rejected by the rest of the network. So they had to revert back. So that's what happens.
Okay, thank you.
Yeah, but it's a good question. That's like the very first question you should have. That what happens when somebody cheats? How do we defend against that? And the answer to that is the Bitcoin network has inbuilt independent validation mechanism which is not dependent on a centralized miner. So if you have like 2 or 3 major mining pool, that's called mining centralization, and that's a valid threat on Bitcoin. If you have too much mining centralization, you can have situation like block size war. But even in those situations, the network and the rest of the economy moves in certain ways and does certain things that the miners does not feel the power anymore. Ultimately, the miners are service providers for the networks, and the miners are only profitable if they follow what the network wants them to follow, or what is valid by the network. If they create something invalid, if something that is considered invalid by the network, they will not earn their profit, and that stops them operationally to stop doing something invalid, right? So that's the roundabout way of solving the Byzantine generals problem. So the interesting thing about it is like the Byzantine generals problem was not solved for so many years because you cannot solve it mathematically. There is a paper in 1998 published by MIT that says like you cannot have a general solution of Byzantine generals problem in a in a network which has any more than 1/3 of the nodes which are attackers. In any kind of setup or environment like that, a general robust mathematical solution of Byzantine generals is impossible. Like they mathematically derived why it's impossible, so there is not even point of trying to come up with an algorithm which is mathematically impossible to do. What Satoshi did is kind of like a roundabout way of creating a system which does not work in theory, But in a very large economic scale where a lot of people are involved with a lot of social chaoses and network effects of second order and third order kicking in a whole, you seem to be able to solve the system, right? So 51% attack is the first comment that got received in the mailing list after Satoshi published this paper. Somebody did this math and came up that it does not work if 51% of the miners are malicious. And that's true, right? And the answer is, what happens is like weird things happens. Social dynamics happens, capitalism happens, and economy happens, and market effects kicks in, and in such a way that it ends up like reverting the miners politically, backtracking from their decision of doing something invalid because purely of profit motive. I hope that makes it clear, but I cannot make it more clear than this. And the good resource on that is the Block Size War. There is a book and that details out all the things that happened. In fact, it can happen again. Like there could be another instance of a consensus battle that can happen. So, okay, Fazil, go ahead.
Yeah, I mean, my question is not directly related to the white paper, but it stemmed out of something that we discussed a few minutes ago. Why are we storing data pertaining to orphan blocks when orphan blocks do not serve any utility anymore? Is that not adding a lot of load on the nodes? They're storing data of a block that does not serve any purpose anymore.
Mm-hmm. Yeah, it does. The only reason it got it's still there and it's not pruned yet, or I'm not sure whether version 26 prunes it. Probably it does, because there was a conversation going on, because it does not make sense to keep them around, but there is a decision to make, like how deep you do the pruning. And that's a decision nobody wanted to make because of like the reason of Bitcoin development and the messy nature of its chaotic like the development process. So nobody wanted to touch upon that question, and because like it wasn't a very pressing need, because the blocks are not, orphan blocks weight is not that big, it's like few MBs and stuffs like that, even in the entire blockchain history, and it does not happen very often. At the same time, we do not want to like throw away orphan block that is 6 depth away or 10 depths away. Could happen a reorg, so you need the orphan block, but anything beyond 100 depths should be okay to prune. And I think Bitcoin Core does that. If anybody knows the recent state of that, can chime in, or I will have to scour up that PR from the repo. But yeah, it does not serve any process. Once it's orphaned on, once enough block has been built on the other chain, it's kind of orphaned. You can't use it for anything. It's just unnamed data that does not mean anything anymore.
Right, thanks.
Okay, anybody else raise their hand? Surya, yeah, go ahead.
Yes, Surya here. Can you hear me?
Yes, I can.
Okay. I am a first time attendee here. Okay.
Right.
Yeah. So this may be little out of the agenda of this call, but then interesting to understand the quantum computing threat to Bitcoin network. Just I mean, out of curiosity, just if someone is closely following that, maybe.
Right. I haven't been following that closely, and I'm not a quantum computing expert at all, but it has been in public sphere talking, and in general, like the research and development of cryptography space a lot. Quantum computing affects the hardness properties of cryptographic construction, and that's a problem for cryptographic algorithms. And we need to come up with algorithms which are quantum computer resistance. What happens in Bitcoin when quantum computer starts breaking ECDSA, public key cryptography? I don't know. We probably move to better cryptography or like another cryptography, but it's not going to affect only Bitcoin. It's going to affect many other things, because public key cryptography is kind of ubiquitous on our internet right now. It's everywhere. And so if public key cryptography gets broken, everything gets broken. So there are like various candidates of valid quantum resistance algorithm, but so far what I have read, um, that it's kind of heavy in terms of like data footprint and computation footprint, and I guess like it was those kind of questions like what happens when we run out of like byte space in the timestamp failed for the block, and we cannot represent time anymore. What we do then? That's a hard fork, or it's gonna be a fork of some kind, and it's gonna be a change, and the whole network needs to agree with that change, and we will have to do it. So we'll figure out how to do it, and so far it does not seem like a threat immediate enough that the Bitcoin core developers are at least worried about it or working towards it effectively. But it's a thing that is on the horizon. Could get in next 30-40 years. I don't know.
Okay. I think meanwhile we can extract whatever we intend to extract from the network.
Yeah.
It's far away, I think.
Yeah.
Thanks a lot.
Okay. Cool. Any more questions?
Just one more. Just wondering the Lightning network, how it compares to the Bitcoin network, and how Lightning network is more intended for micro payments. Just a little comparison.
Yeah. So like lightning contract or lightning in general is a protocol on top of Bitcoin, and that's the way to put it. It's like Bitcoin. Satoshi didn't talk about the scripting system in the white paper at all, but that's a very important part of Bitcoin's design. And what it allows us to do is like create smart contracts, and one of those smart contract is Lightning. And what it allows us to do is like create some kind of like quickly updatable payment state between two individuals, where we can pass around back and forth Bitcoin transactions very quickly without looking for on-chain settlement. Now that these are all heavy words that I just use, but explaining Lightning in shorter terms is almost impossible. In gist, it means like it's a mobile app, it's a feature on top of Bitcoin that you can have, and some wallets provide you that, where you can do like UPI kind of instant transactions. And in Bitcoin on chain, you have to wait for confirmation, and depending on the congestion and the traffic in the network, that can be a while. In Lightning, they just get the sats immediately.
Okay. The reason was like I have seen videos where people in El Salvador are on the fly making payments using the Lightning network.
Yeah.
Like how we use UPI here.
Exactly.
So that is where my curiosity.
Yeah. So so you can think of Bitcoin as the central bank and the Lightning as the UPI. Right. So, or not the central bank, or the banks, basically the entity that handles settlement. Right. So Bitcoin is the bank and the Lightning is the UPI. In fact, like the UPI design is very similar to Lightning, and Lightning is what happens when you try to do UPI on top of Bitcoin. That's one way one guy put it. I'm not an UPI expert, or I haven't looked into it, but that's what one UPI guy told me, that it's basically very similar to the construction of Lightning.
Yeah. So just wondering if Satoshi is there now. I mean, looking at the L2 improvements going on Bitcoin network, right? I mean, many Bitcoin proponents, I think, disagree with that activity, I think. Right?
Yeah, I guess like, yeah, many people have their individual views, and Bitcoin is like, even if it's a community, it's a very individualistic thing. We make our own research and we do our own judgment, and never trust verify that goes with the ethos, and not only just the protocol but also individuals. So many people have differing deep opinions about almost everything in the Bitcoin space, right? Nobody agrees on the two different things, apart from maybe like eating more meat. And but yeah, Satoshi watching or not, I don't know, anybody's guess. Maybe he is. I like to believe that he is. Maybe he's part of the community in some other name that we don't know about, and that guy is like keeping quiet and not saying that he is the one.
Okay. What is the rough estimate of Bitcoin he's holding? Just out
1
of
million.
curiosity.
1 million. Yeah.
Imagine if that moves. It can
Yeah,
break or make.
there are like red like sirens targeted towards those Satoshi coins, and if any one of them moves, but the whole world gets to know.
Correct.
Yep. Okay, we will not extend further. That has taken enough people's time. We are almost at the 2 hour mark. So thank you everybody for joining in. Thank you Shreyan for hosting and helping us through the read through, and everybody for chiming in their questions, thoughts. And next one, we will do our usual reading club session next week, Wednesday, the Bitcoin Dev Philosophy. And this one is recorded and will be published in our YouTube channel. So stay tuned for that. And till then, catch you guys around. Have a good week, good night, and have a really happy new year. Bye bye.